everyone. In this video, we are going to understand the most important topic in natural language processing. So we are going to discuss about language models. So what is meant by language model, right? So it is a statistical tool which is used to predict words. So let me give a simple example, right? So you are talking to one of your friends and like he starts saying something. Before that you may be predicting that what he is going to complete, right? So this is a psychological way, or whenever we talk to our friends or whenever we talk to someone, or like by listening to few words in the statement, then we really try to understand what the particular means to say, right? So a language model is a statistical tool to predict words. So for example, there are a lot of weather models, right? So it predicts the 7-day forecast. So language models try to find out the patterns in the human language. So predict the patterns in the human language means they are used to predict the spoken word enunciation. Like basically it tries to identify the next word or the next, I mean the next word in a particular sentence, right? So we all know that images have dominated the field of AI. Similarly, the language models are the next frontier for artificial intelligence. So images were more accessible for modeling tasks because they are easier to label and they have computer interpretable information already, which is being encoded in pixels. But this language modeling is being more challenging for modelers because language is complex. Language has layers of meaning. Language changes from context to context. Language changes from sentence to sentence, author to author. See, if I speak something like it could be related to something like which may be related to my domain, or when somebody else speak, it could be related to his domain, right? So sentences are also harder to label than so a language model learns to predict the probability of a sequence of words. Say, for example, like I have given an example, right? The is a single word. So from this the, we cannot predict anything. So the next the word gold is added to that, the gold. Okay, so what is it about, right? This is how the mind thinks. Now the third one is the gold price. So we are going to talk something related to gold price. And the next one is about the gold price fell. And the next one is about gold price fell again. So it's going to talk of something related to from the past. It is connecting to something, right? So again today for a third day. So I have not written everything because that's why I have kept dot. So fell again today for this, I mean, the gold price, no, the gold price starts, fell again for a third day. So like it could be about the gold price, it could be about the stock, right? So when we get to know that the third day, or no, it could be third minute or whatever it is. See, for example, the stocks fell again today for a third. So once it end, like it could be like a third day or what it basically, right? So this is what we are trying to identify. So similarly here, the gold price fell again. So here also we are trying to predict this, right? So what are we doing over here? We can narrow down the choice of next word and sometimes even get it right. Fine. So this is what we are trying to understand now. So basically we will try to understand how these language models basically work. We all know that computers can only read numbers, right? So computers can read only numbers. So in order for a language model to be created, all words must be converted to a sequence of numbers for the computer to read, right? So for modelers, we call these as no encodings, right? So this encodings can range in complexity. At the basic level, every word can get its own number. So this is basically called a label encoding. So label encoding assigns one number for each unique word in a sentence. Say, for example, I have an example: the boy sat by the tree, something like this, right? So we could represent the sentence by certain numbers like 1, 2, 3, 4. So again, this is the, so I'm going to write it as 1, and the next one is 5, right? So this is the most basic encoding one could give a set of words, right? So when we talk about this no language model, in 2014, word2vec was discovered, right? Word2vec was discovered, and like it was being a very popular encoding method. After that, encodings have greatly evolved from label encoding methods to one-hot encoding methods, to word embeddings. And 2019, from 2019, we are using transformers, right? So language modeling got a big popularity boost in 2019 with the development of this transformer. So last year, 2019, there were 4 major releases of sophisticated transformers, which was being provided by Google, OpenAI, and Salesforce, right? So these transformer models given by OpenAI and Google, they have a lot of computer resources to build, right? And another one I can say that Hugging Face, right? So this is also being used. So now you may be thinking like, what are the challenges? No, what are the potential challenges or benefits of these language models? So in modeling, if we try to predict the, say for example, grade on an exam based on how many hours we studied and whether or not we had our dinner, we would say that the model has 2 parameters. So in the first case, what I said, it was one thing related to time spent studying and whether we had dinner or not, right? So the transformer models these companies have released have been trained on 1.5 billion parameters and are often so big, right? And they can't work on most computers or mobile devices, right? So when OpenAI released its GPT-2 model, it came with several caveats, right? The company said it was a new technology and they wanted to see how the release of the language model would be used by developers first. So the language models pose a threat to disinformation, right? So it poses a threat to disinformation, where deep fakes are putting out fake videos of people. Language models can be used by bad parties to create junk news or increase catfishing scams through fake text messages, emails, and social media status updates. So articles generated by a machine continue to be released that look like other people actually wrote them, right? So, but the models may also have a place in the creative arts, which we are only just beginning to see. So Hugging Face made its models available in an interactive user interface, right, with the transformer. So anyone can see how the technology basically work, right? So it is actually funny to play with, even if it doesn't serve a functional writing purpose, right? So like in the real world where we use it means like Google has included some auto completion services in its Gmail, Gdocs, G Sheet services. So it is being used to help coders write better code with autocomplete and autocorrect functionality built in or as add-ons on their preferred IDEs. IDEs are nothing but integrated development environment, right? So we have reached a tipping point in the possibility and potential of language models. So before a new encoding method could increase the performance of its predecessor by 15 to 20%, now the industry is seeing its diminishing returns and new models to arrive on the scene only have a tenth of a percentage point improvement on the old ones, right? So now let us have a discussion on Ngram model, right? So we will try to understand what this Ngram model is. So as I told you, Ngram is a sequence of N tokens. tokens are nothing but words, right? Tokens are nothing but words. So we are talking about the Ngram modeling, that is text modeling, right? So like we will try to understand what it is. Say, for example, I love reading blogs about astronomy, right? Astronomy. So here a unigram or 1 gram is a one word sequence. So here the unigrams would be simply I love reading blogs about astronomy. So 2 gram or bigram is a two-word sequence of words like I love reading blogs about astronomy, right? Something like that. And the 3 gram is a three-word sequence of words like I love reading, say I love reading about data science, something like that, right? So if we have a good Ngram model, we can predict what is the probability of seeing the word W given a history of previous words where the history contains n-1 word. So what I try to say here is, based upon the previous words, if I'm trying to find out the probability of the given word, this is what the Ngram model tells us, right? Fine. So let us look into this and then we will have a deep discussion on it. P of W1, W2 up to Wn, which is equal to P of W1 into P of W2 into W3 up to P of Wn minus 1. So how can I understand this better? P of the Prime Minister of our country, right? Which is nothing but probability of the into probability of prime into probability of minister into probability of into probability of R into probability of country, right? So here what we can see, probability of the prime minister of our country, right? This is what I'm trying to understand or trying to solve now. So probability of the, that's going to be the first word. And now probability of prime, the given word is the, right? And probability of minister and prime is given. Probability of, no, this is how this actually flows, right? So in the next case, what I have taken, probability of W1 up to Wn equal to probability of W1 into probability of W1 given, sorry, probability of W2 given W1 into probability of W3 given W1 comma W2, right? So this is how this actually goes on. So I'm trying to find out this one, which is nothing but probability of the, that is probability of W1 into probability of W2 given W1. So what is the first word over here? The. So probability of prime given the. So probability of minister given the and prime, and probability of given prime minister, right? This is how it goes. So simple, right? So probability of Wn given Wn minus 1 is equal to count Wn minus 1 comma Wn divided by count Wn minus 1. Say for example, probability of minister given prime, which is equal to count prime comma minister divided by count of prime, right? So probability of trigram probability. So probability of Wn given Wn minus 2, Wn minus 1. Try to understand the difference between this and that. Here we are trying to predict this word given this, right? So here you can see that like probability of this given this and this, right? So count Wn minus 2, a count of Wn minus 2, comma Wn minus 1, comma Wn divided by count Wn minus 2, comma Wn minus 1, right? So probability of given minister, comma prime, which is equal to count of prime, comma minister, comma of. Basically, n minus 2, n minus 1, n, right? So we are trying to basically find out this one, right? So that is what over here. And these are the two words before that, right? wn minus 2 and wn minus 1 divided by count of prime comma minister, right? So hope this is clear, right? Fine. So now let us understand this in detail, right? So what is meant by n-gram? N-gram is a contiguous sequence of n items from a given sample of text or speech. This is what Wikipedia says. So items refer to states in Markov chains. Items can be characters, words, or sentences, etc. So let me take the whiteboard. Let us try to understand this in detail. All right. So we are basically trying to understand Ngram modeling, right? So it is a contiguous sequence of n items, right? Sequence of n items from a single word. So if n is equal to 2, then it is bigram. If n is equal to 3, it is trigram. If n is equal to 1, it is unigram, and on. So in case of character, in characters or the states of Markov chains. So we had the Markov chains where we had the state, then from state A, we can go against that state. So actually it is Markov in the sense it is about a movement from one state to the another state, right? Say for example, there is an example. The parrot is flying in the parrot is flying on the blue sky, right? Flying on the blue sky, right? Say for example, I'm taking n is equal to 2. Say for example, I'm going to take according to this one. So what's happening is th, right? Then the next one will be he, then the next one will be e space, then the next one will be space and p. So this is how it will work. If I take n equal to 3, he space e space p, right? So space p a. This is how it will be done, right? So here we are considering length as 2 or 3. So we can here the window is moving as such, right? So once th is done, then it is moved to the next window is selected with the even here the space is being included, right? And we are very sure that this is being moved by window, right? So this is what we have to understand, right? So it is not necessary that it should happen letters by letters. It can happen word by word also, right? So the parrot, and like maybe I'm trying to predict the third one, the parrot is. Then the parrot is, after that, I'm trying to predict this flying. The parrot is flying. The parrot is flying on. So it depends upon the gram what we choose. Are we going ahead with a bigram or trigram? That is what it depends. Hope this is clear to you. So we will be understanding these models in detail, because why we are having such a deeper understanding about this model, because this is really important when you go ahead with the modeling kind of stuffs, right? So hope this is clear to you. Let us meet in the next session. Thank you.